Hi, I'm Michael DiSpezio and welcome. In this lesson on energy, we're going to examine thermal energy and heat. Now, the basic question that lies at the foundation of this lesson is, what is the relationship between heat and temperature? But before we get into the lesson content, first, I'd like you to take a look at these statements and say whether you think they are true or false. First one, kinetic energy is the energy of motion. What do you think? Yep, it's an easy one. That's true. We've talked about this in previous lessons. Kinetic energy is the energy of motion. Next, the particles that make up a stationary object do not have kinetic energy. It's a little bit harder one because the answer is false. The particles within the object, although the object might be stationary, its particles have movement. Therefore, they have kinetic energy. Let's look at that next statement. The average kinetic energy of an object can be measured by a thermometer. And that, you know, is true from our last lesson. And finally, particles that make up gases have more kinetic energy than the particles that make up liquids. And that is also true. Remember, it has to do with the speed of the particles. And as you go from solid to liquid to gas, the particle speed increases. Therefore, the kinetic energy also increases. Take a look at this illustration. I want you to think of a caption, or if you have a piece of paper and pencil, write it down. Write a caption for this illustration that includes the concept of the kinetic theory of matter. I'm looking at this, and what I can think is that, well, we have areas in this photo that represent the solid, mountain, liquid, water, gas, the atmosphere, and we also seem to have giant magnifications of what those particles might look like. And in a solid, such as that mountain, the particles are packed together. In the liquid, they're a little bit further apart and they're moving and flowing. And finally, in the gas, they are less concentrated than the liquid. They're spread out more and they're moving faster. And that is the way that I would caption this based upon what I already know about the kinetic theory of matter. Thermal basics. What is thermal energy? A thermal energy is the total energy, the total kinetic energy of all the particles that are in a substance. And if we look here at the particles, we can see that each individual particle has kinetic energy. And remember that kinetic energy is a function of both the particle's mass and its speed. The larger the mass or the faster it's moving, the larger the amount of kinetic energy. But for now, I need you to see that any substance or an object is made up of many particles, and each of these particles has their own kinetic energy. And if we add up all of those individual kinetic energies, we get to the concept of thermal energy. Now, thermal energy is measured in units called joules, which are represented by a J. So what is the difference between thermal energy and temperature? Well, you now know that thermal energy is the total kinetic energy of all the particles. It's the sum of all of those particles that are in a substance. What about temperature? Temperature is not the sum, but temperature is a measure of the average kinetic energy of the particles. So temperature does not include or add up all of the individual energies. What temperature does is look at it as an average. And you know, we might be able to see that difference if we compare the water that's in a glass with the water that's in that large lake. Now, a glass of water can have the same average kinetic energy, the same temperature. Say it's 40 degrees Fahrenheit, the water that's in the glass, and it's 40 degrees Fahrenheit, the water that's in the lake. They have the same temperature. They have the same average kinetic energy. But think of that lake. That lake has so many more particles that the total amount, the sum of energy, the kinetic energy, there is much more thermal energy in that lake than there is in that glass, although the averages, the temperature might be the same. So what is heat? Well, heat is a form of energy. It is not the same as thermal energy, and it is not the same as temperature. It is different from both of those. Heat is the energy that is transferred from an object at a higher temperature to an object at a lower temperature. So heat is really a measure of energy flow. And heat always flows from something that's warmer to something that's cooler. It goes from hot to cold. It never goes from cold to hot. Heat always travels from hot to cold. So how is heat measured? Well, heat can be measured in two ways, and we can use two different units. One method uses the unit called a calorie, represented CAL, and notice it's a lowercase c. And 1 calorie is equal to the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Now, in nutrition, we use another type of calorie, and you've probably heard of that calorie when you think of foods. But this calorie contains 1,000 of those other calories I just talked about. It's a kilocalorie. But we can represent this as a calorie with an uppercase C, and we can use the symbol of an uppercase CAL to represent this type of nutritional calorie unit. To find out how many calories are in a food, scientists use an instrument called a calorimeter. And a calorimeter is a central chamber surrounded by a water jacket. And food within that central chamber is burned. And as it's burned, it gives off heat energy. That heat energy transfers to the water. What happens to the water? That's right, it heats up. And by analyzing the rise in temperature, scientists can determine the amount of calories that were in that food. And that is how you are able to quantify, to figure out how many calories are in various types of foods. So we look at a rise in that temperature and we equate that with the calorie content of the food that is burned. How is heat measured? Well, heat can also be measured in joules because heat is a form of energy. And I mentioned that before. So we have heat and it can be measured in units of calories. Remember, two different types of calories. And it can also be measured in units called joules. And we can convert, we can change these values between the two different scales. 1 calorie is equal to 4.18 joules. How can heat affect the state of an object? Well, the state of a substance or the phase of a substance depends upon the speed of its particles. Let's go back to that picture before I had of the lake and the mountain and the sky. And we can see that in a solid, the particles pretty much are fixed. But as you add energy to them, they begin to vibrate more and more and more. So the speed of the particles is being affected by the heat which is transferred to that object. In liquid, as we keep adding more heat to it, those flowing particles begin to move faster. They flow faster. And in gas, they are moving very fast. And as we keep adding heat to the gas, those particles move even faster. So you can see that heat, the transfer of that heat energy into a specific, whether it's solid, liquid, or gaseous, to a specific substance or object, causes its particles to move faster. Now, the state of a substance depends upon the speed of a particle. We can also change the phase, the state of that substance, by heat, by adding more kinetic energy to it, going from hot to a cooler substance. So if we add energy in the form of heat to a substance, such as right here we have ice that is in the solid phase, and what we're going to do is add heat. Heat energy is being transferred now to that ice, And that ice, well, eventually it will begin to change state. It will begin to change phase. Because remember, in the solid phase, those water particles are locked rigidly in a crystal structure, but as they gain heat, kinetic energy, look what happens. They begin to free themselves up from that locked position and they begin to flow. And that is when we have the liquid or a fluid state, which has occurred. Now, how is heat transferred? Heat can be transferred in one of three main ways. The first is called conduction. Then we have convection. And finally, the heat transfer called radiation. Let's look at these specifically. Conduction. What is conduction? Conduction is the transfer of energy as heat from one substance to another through direct contact. Have you ever accidentally picked up something that was hot and you dropped it? Well, that heat was transferred directly because you were in physical contact with that hot object to your hands. And so that is one form. It's called conduction. And as long as two objects remain in physical contact, the conduction continues. That transfer of heat continues until the temperatures of the objects are equal. Now, there's two different types of materials when it comes to the conduction of heat. One is actually called a conductor. And a conductor is a material that transfers heat very well. And metals are a good example of conductors. The other type of material is called an insulator. And an insulator is a material that is a poor conductor of heat. And good examples of that might be wood or paper or plastic foam. They prevent the easy transfer of heat. Now, another type of heat transfer is called convection. And in convection, we have the transfer of energy as heat by the movements within a liquid or within a gas, within fluids. And convection occurs when we have a warmer part of that fluid, which becomes less dense. It rises up, and then eventually it'll spread out. It'll cool, get more dense. And what happens when it gets more dense? That's right, it descends. It goes down. But once it's down, it warms up. You know, we can see that in this illustration here. First, let's add some heat energy, and that heat energy will be transferred. The kinetic energy will be transferred to the fluid. The fluid begins to warm up. It becomes less dense. It rises, spreads out up at the surface. It cools because it's far away from that flame. As it cools, it becomes more dense and it begins to sink. But when it sinks, it gets right down to the bottom. And through conduction, with the bottom part of that container, it warms up again. And as it warms up, what happens? That's right, it becomes less dense and it rises back up. Now, the movements within these fluids are called convection currents. And the currents that connect forming those circles, all of those currents together are called a convection cell. Finally, we have radiation. And radiation is the transfer of energy by electromagnetic waves. And it sounds complex, but you know what? You've experienced already. You've experienced this already. If you've ever seen a fire and placed your hands up or in front of a radiant heater, you can feel that warmth. That's because the heat has traveled by radiation to your hands. And when radiation is emitted from one object and is absorbed by the other, the result is often a transfer of heat, and you can feel that transfer as your hands feel warmer. Now, radiation can travel through empty space, which is a good thing because the radiant energy of our sun, the energy that's created in our sun, is broadcast out from this nearby star, and it bathes our planet, and it becomes the ultimate source of most of the Earth's energy. So in review, how is heat transferred? Well, it's transferred in three ways: conduction, convection, and radiation. Take a look at this illustration. Which of these captions best points to conduction? Which one? Yep, you've got that right. It is the spoon. The spoon is gaining heat energy. Its temperature is rising because we have heat which is transferring from the warmer liquid to the cooler metal. What about convection? Well, the giveaway are those colored arrows because they're showing convection flows, forming that convection cell. And so we have convection, which is the heat transferred by the particles of a fluid. And finally, which one is radiation? Well, radiation doesn't involve that fluid transfer and it doesn't involve actual touching, but we can see it here from the flame. Just as your hands would feel the fire, the flame is radiating heat, energy, which is transferred to that liquid, and we have the liquid warming up. So in summary, let's take a look at this lesson. Thermal energy is the total kinetic energy of all particles in a substance. Remember, it's not temperature. Temperature is the average. Thermal involves the sum, all of those particles. Heat is the energy transferred from an object at a higher temperature to an object at a lower temperature. Remember, that is the only direction in which heat travels, from warmer to cooler. Heat can change the state or the phase of a substance. And finally, there are three main ways that heat can transfer. What are they? Conduction, convection, and radiation. And that is it for this lesson on energy. Thank you so much for participating. If you'd like to see more of my tweets, please visit me at DiSpezio, or if you'd like to find out some more cool science activities and things about science, visit us at #HMHScience. Thanks so much, and I'll see you in our next lesson.